I got involved in looking at weather and climate extremes because extremes are what impacts people and things. And one of the reasons that the Centre of Excellence for Climate Extremes got funded was that there isn't another research centre around the world that is exclusively focused on improving understanding in extremes. When the previous Centre of Excellence was set up, there was an extremes research program in that Centre of Excellence. This is now, is it 7 years ago, Melissa, or 8 years ago? She's too busy doing other stuff. I think it was 8 years ago now that it started in 2010, and I was the leader of the extremes research program when it was set up. I moved on to this new position in CSIRO, not because I didn't like the University of Melbourne or not because I didn't like research colleagues in the Centre of Excellence, for a lot of different reasons, but the main one was it was both a challenge and an opportunity to try to lead this Earth Systems and Climate Change Hub. But for reasons that I don't completely understand, I got invited to give the first 2 lectures in this hub. Probably meant that no one else wanted to get up at 9 o'clock on a Monday morning in Canberra. Sorry, 8:30. Although it was cooler where I was last week on Monday, it was -5 or something like that in the morning. It's probably the same, but that was roughly at sea level in the middle of Australia. So anyhow, what I'm going to try to do is give you essentially an introduction to a range of different things to think about and talk about some examples of extremes. But I'm going to start off by talking about, what is an extreme event, what we talk about in terms of extremes in weather and climate stuff. And then I'm going to just talk about 2 what I think are interesting examples of extremes, because both are what are called compound extreme events that have multiple aspects in them which are related to extremes. And here I'm talking about what happened in the summer of 2009 in much of southeastern Australia, and then the, 2010-2011 period, which was again a very heavy rainfall period, and again associated with compound or multiple extremes. And they're interesting because they do have multiple aspects of extremes. But the first thing to do when you want to know about something is go to the Oxford Dictionary and look up the meaning. That's something that scientists rarely do. But I looked up what extreme is, something that's high, reaching an high point, or very great, not usual or exceptional. And an event is something that happens. So obviously an extreme event is something that happens that's not usual or extreme, very severe or serious or high. Now, what that means for weather and climate is really quite interesting. And I'm going to talk about what people mean in weather and climate about extreme events in just a few minutes. But what I want you to do first of all, most of you have sat next to someone you know already. Is that the case? So if you haven't sat next to someone already, or even if you have, I want you to talk to someone either in front of you or next to you or behind you who you haven't met before. Introduce yourself and discuss what you think are weather or climate extremes. What you mean, or you think you mean, by weather and climate extremes. You only get 3 minutes to do this. But introduce yourself and make sure you do it to someone you don't know. What can you remember as the most recent weather extreme that affected you?
Oh, well, considering that we live in Hobart, the rainstorm that we had down there, because that was fun. So I suppose things that are outside of the norm, very far outside the norm.
But doesn't the norm include everything?
I disagree. I'd say that the norm is what you're used to, but then there's something that comes out of, it's beyond the average that you'd expect. It's something that actually, it triggers a warning because people aren't used to it. It's something that a community is not prepared for so much.
But normally when you consider that norm being the whole distribution...
if you want to get technical, But yeah, so that's...
But you're right. But depending on what time period you're looking at, it's an unusual event. But I think what you're talking about is probably unusual on the time scale of, 10, 20, 30 years.
Something like that.
Yeah.
Generally.
So that would be considered in most cases as an extreme.
An extreme.
Yeah.
Yes.
Or like a record.
Yes. Something that's a record.
That's a pretty,
Have you seen this website that some of our students put together? It's called Is It Hot Right Now? And it says, hell no, you're kidding, it's bloody cold. And then they've got today, and then they've for all cities over Australia, three of our students put it together.
So how cold is it? It's not,
Minimum temperature overnight was 5.6.
Oh, but this is for the 25th of June.
Yeah, so they do it for...
But you've got to do it for all of June and it wouldn't be so extreme. Yeah. And I'm hoping that was useful in two ways. First of all, you met someone you haven't met before, perhaps, that was the idea. And also you've started to think about what extremes mean in the weather and climate context. And there was, in fact, in the IPCC, a special report on weather and climate extremes, and it defined what an extreme weather or climate event was in the context. I'm not sure I completely agree with this definition. It talks about an extreme weather event being something in the tails of the distribution or above some threshold, which might be some temperature threshold or heavy rainfall threshold. If you're talking about a summer day in Australia, then 40 Celsius or 45 Celsius might be considered to be a very hot summer day. In the second lecture I'm going to talk about is a commonly used definition of a summer day threshold. Can anyone guess what the summer day temperature threshold used commonly in a... Correct. 25 Celsius is used as the hot summer day threshold in a global database. So we might get a few autumn or spring hot summer days in many parts of Australia. So you've got to be careful with definitions, particularly when you talk about thresholds, because the threshold you choose is often location specific or season specific. But in fact, when we talk about extreme events, often it's the impact that is used to define the extreme event when we're talking about the impacts of weather and climate, because it's the impact that might well determine the relevance. And often when we're thinking about extremes, we need to think about the impact of that extreme. In addition, we probably need to think about how extreme the extreme really is, because different definitions of extremes, are we talking about something that happens once a year, once every 20 years, or once in 100 years? Because when we talk about return periods, we're talking about the average interval, time interval between these extremes. And a once in 100 year event is probably pretty rare, probably sets a record. That's the sort of extreme that's often used in designing bridges or dams. Most of us don't want to be standing below a dam or standing on a bridge that's going to collapse because we had once in 100-year rain. But actually, for many of the extremes that are defined in standard metrics or measures for weather and climate extremes, we don't look at once in 100-year daily events. So we've got to be aware that when we're talking about extremes, who you're talking to, whether it's a hydrologist or an engineer, who are trying to build safety so that it doesn't happen very often, or you're talking about the global climate not exceeding a 2-degree threshold with a 50% chance, those are very, very different types of consideration. Are you looking at something that's going to happen once in 100 years with daily data? That probably means it's 100 times. Well, if we're talking about a summer extreme, it's once in 10,000 days. Or if you're talking about rainfall, might be once in not 365 times 100 years or 36,000 days because it doesn't rain every day. But those are relatively rare extremes. What this diagram at the bottom is trying to do is to show that actually the impact of extremes is determined not primarily by the weather and climate events, but the combination of whatever system is being affected, whether it is rainfall affecting a bridge or a dam, in which case it's the vulnerability, how strong the system is, and the exposure, how much that is being affected, not just by the rainfall, but also by the catchment area, things like that. And this can apply to lots and lots of different types of extremes, but often it's the impact of that extreme. And if that extreme happens over the ocean, away from any people, any ecosystem, it may have negligible impact. We're much more worried about extreme tropical cyclones or hurricanes when they're close to coastlines or islands than we are about the extreme tropical cyclones or hurricanes in the tropical Atlantic Ocean. So it's the impacts that are often what defines an extreme. Now, we've also got to think about the spatial scale and the temporal scale of extremes, because they can have dramatically different scales. Some of the highest impact extremes have some of the smallest spatial scales. Things like tornadoes, which do exist in Australia as well as in North America, in the United States. They, in fact, exist on almost all continents, have very small spatial scales. They have major impacts. But we're not going to focus on those because it's actually very difficult to get good data for long time series. We can also look at the differences in spatial scale when we think about defining the extremes, and I'm going to talk about this in a couple of minutes. We talk about extremes, and I've talked about it a little bit already, and the language that's used about these extremes is sometimes not very precise. We can talk about extremes that have high impact, but particularly in terms of rainfall, it may be high impact because of changes in the system, like rainfall in urban areas is often affected by changes in the runoff but not always is it going to be an extreme rainfall event. It might be a relatively normal event that happens in a location where it has a major impact. Many of the extremes metrics that I'm going to talk about in the second lecture are not extreme extremes. They're relatively modest or weak extremes. For instance, we often use percentile thresholds, and a number of those use exceedances of the 10th and 90th percentiles. Cooler than the 10th or hotter than the 90th or wetter than the 90th or 95th percentile. Well, one day in 10 should on average be cooler than the 10th percentile, and another day in 10 should be hotter than the 90th percentile. Those aren't very extreme, and yet they're used a lot because often you can get more robust data for changes in extremes, not by looking at the 99.9th percentile, the tail in the distribution, but looking at the modest tails and looking at all the exceedances of the 10th and 90th percentiles. But one of the biggest problems is that if you look at very rare events, by definition extremes are rare, unusual. You have much less robust data in weather and climate data, and these tails can be highly sensitive in any sorts of data sets to the system that's being used to estimate the extremes. So whether you're talking about observations or models, they can all have major deficiencies in representing the extreme tails, like the 1 in 1,000 event. The 99.9th percentile doesn't happen very often and is difficult to estimate robustly in a model or in observations. So we need to be careful when we're thinking about extremes to try to make sure that we've got a balance between the robustness or otherwise of the data we're using, whether it's models or observations, and what it represents, and are we actually looking at something that's important, and how do we interpret it? So I'm going to come across this much more, talk about it much more, when I go to the next lecture, talking about extremes and metrics or indices that are used to represent these. Because what you're going to find is that you can interpret some information, but you may not be interpreting it accurately or reliably based on the data that's included. So as I've said already, we can think about differences in spatial scales, whether it be hailstorms or tornadoes, severe convective events, out to very large scale extremes, droughts and heat waves. We can think about the time scales for droughts, typically a season to a year or longer. Compared with the timescales of a hailstorm or a tornado, which might be 5 minutes out to half an hour. And you're going to need very, very different data sets, very, very different observational systems to look at those different. The other thing we talked about a few minutes ago was temperature extremes in Australia versus globally for summer days. What is a hot day in Australia is an extremely extreme day in the UK. And in Iceland, they've never had days over 40 degrees Celsius. So the context of talking about metrics and thresholds in one location is critically dependent on the climatology of that location. So we've got to be careful when we're looking at extremes. When we're talking about a hot day or a wet day, a wet day in Melbourne or in Canberra is not an extreme day for the tropical north of Australia. Average rainfall in Canberra is about a fifth of the average rainfall in Darwin. It's actually a little bit less, a little bit more than that. It's more like a third. But in practice, what that means is that for the extremes in rainfall as well as extremes in temperature, you've got to worry about the climatology if you're using absolute thresholds. I talked about impacts. This is from a WMO assessment. There have been massive both infrastructure impacts, economic impacts, and deaths associated with weather and climate extremes. And these are the main reason why people get interested in understanding extremes. But we have some major issues in terms of both data quality and scientific understanding. You're going to hear much more about that over the rest of this week. We're not going to focus in the rest of the week on the economic costs. We're really going to focus on the scientific understanding of different types of weather and climate extremes. And you're going to hear from temperature extremes and rainfall extremes and severe weather events. You won't hear everything, but most of them are going to be covered. So before I go on, does anyone have any questions or comments that they want to raise about anything that I've talked about already? Yep.
So you mentioned a lot of observational data sets and model data sets struggle to get the tails of distribution right. You're talking about extreme of some variable. Could you give some examples of data sets that are particularly bad and ones that are particularly good in that regard?
Well, most station-based instrumental data sets that have data for extended periods struggle to retain robust, statistically homogeneous distributions of extremes. And the reason is that every time there's a change in instrument location or instrument observing type, there's very likely to be change in the tail of the distribution. The ACORN-SAT temperature data set, which is the high quality daily temperature data set for Australia, every station, every site that is used has adjustments. And that's the highest quality data set available, and they pick the best stations. So it tries to have data from 1910 up to the present, and every station location. Melbourne recently relocated its continuous observing site. It's happened a number of times in the past from essentially the northern part of Melbourne on a triangular small block of land next to the Royal Society of Victoria building to the tennis centre, which is closer to the river and lower elevations. It's a colder site, and it definitely has more cold extremes because it gets cold air drainage. And they haven't adjusted it yet to make it consistent with the ACORN-SAT data. So you can't use temperature extremes from Melbourne's observing site, with any of the historical records for Melbourne, reliably. Best estimate that I got from Blair Truen, the expert on weather data from everywhere, is that there's about a 1 degree cold bias in winter in the new Melbourne site compared with the previous one. So in models, you get the same sorts of problems, because how do you represent an extreme which might occur at a spatial scale of a few hundred meters or even a kilometre in a grid, global climate model grid, which is at 100 kilometres? You can represent extremes, but they're extremes in the model space. And comparing model and observational extremes can be quite difficult. Any other questions or comments? So one of the issues that was just raised is related to these sorts of distributions. What is shown up here are representations of the variations of temperature and rainfall and the possible shifts in that associated with human-caused climate change. But I'm going to talk about these in terms of site shifts. Because a site shift, for instance, in a temperature or rainfall observing site, particularly is likely to change the temperature. If you take an observing station and move it from one location to another location which is, for example, 50 metres lower in elevation, what are you going to expect its mean temperature change to be? Increase. And how much? About half a degree, likely a little bit less than that, but not much. It's usually 6 to 7 degrees per kilometre lapse rate. And 50 metres is a 20th of that. That's going to shift the distribution in the opposite way to this. But it's going to cool it down. And that's going to have impact on the cold tail. Change the observing instrument. For rainfall extremes, go from a rain gauge, a cylinder with a catchment, to a tipping bucket rain gauge, and you will have different characteristics in the rain catch depending upon the wind and the intensity of the rainfall. So instrument changes and location changes are going to change these sorts of distributions, and any change will much more affect the extremes than the mean. And what that means is that we have to be particularly careful in data assessments with observational data and climate model data in looking at changes in extremes, because it may be easy to say that the change has been due to human-caused climate change or hasn't been due to human-caused climate change. But some of those extremes might be due to changes in observations, changes in instrument type. Why does the Bureau of Meteorology only report temperature data in its long-term statistics after 1910? 1900 was the start of Federation.
Were they non-standard measurements of temperature? Or were they changed the way, like they added the Stevenson screen?
There was a standard observational process in each state, but it wasn't a standard observing enclosure for the thermometer. There was some used in South Australia that were different to the ones in Victoria, and it took a while for Federation to break down some of the barriers between the states. I think it's still difficult to break down some of those barriers in terms of sporting codes. But what happened was a standard instrument shelter, the Stevenson screen, was introduced in 1907 to 1909. And it's only after 1910 that the standard Stevenson screen for observing temperatures was introduced. Now, the really interesting thing is now these Stevenson screen, we don't have one here, was a sort of white slotted enclosure. Those are now being replaced by automatic weather stations, which have a much smaller enclosure for representing extremes. And there has been assessments done that show that there's a slightly faster response time. And they've had to adjust the temperatures to get a more appropriate response time, to measure the maximum and minimum temperature. We also have to think about, when we're talking about extremes, what the Bureau of Meteorology measures as the hottest temperature or the coldest temperature. And it's all in shade, in a well-ventilated region. It's not what a tennis player feels in the middle of the tennis court for the Australian Open, or what you might feel as you walk across the street. It's important to recognise that standard measurements are the best for obtaining appropriate representations of homogeneous data over long time periods, but they're not what affects structures, why the rail tracks buckle. They're not what affects people, and they're not what affects plants or animals or fish. So critters experience what is local. You've got to remember that, because as was reported frequently with the Australian Open, you can get temperatures in centre court, in the sun, on a blue coloured surface, which is 55 degrees Celsius or 60 degrees Celsius, and yes, you can fry an egg on it. Slow cook it maybe, but yes, you can fry an egg, as has been demonstrated on TV. Whereas the air temperature might only be 41 in the shade. So think about that when we're talking about extremes. There have been large changes in extremes reported for many parts of the world. Increases in hot extremes and reductions in cold extremes in most parts of the world. And you're going to hear more about that later on, as well as increases in heavy rainfall events, and you'll hear more about that as well. One of the most interesting things is that there are different parts of the world which have experienced very different changes in drought, and Australia is one of those regions. Northern Australia has experienced reduction in drought, significant reductions in drought over the last 100 years, and Southern Australia has experienced significant increases in drought. And that will also be discussed later on. So what I'm going to do now is talk about two of my, it's hard to describe them as favourite, most interesting compound extremes. Because they had major impacts, because they are record-breaking extremes, and because they're compound. They have multiple different components. So before I talk about these, any other questions about the extremes that I've talked about so far? Anything you want to raise? You guys are too quiet. How come you could talk so much when you were talking to the person behind me? I'm not a scary person. There's no such thing as a bad question. They're all good. So, certainly for people living in southeastern Australia, late January and February of 2009 were extreme. And the bushfires on Black Saturday killed more than 170 people. It is the largest death toll associated with any weather-related extreme event as frequently reported in newspapers. However, that's wrong. More than twice as many people died in the heat waves that happened a week earlier. That was the largest death toll of any weather-related extreme. But you'll hear the fires talked about as the biggest extreme. So the combination of the heat waves and the fires caused massive death rates. They were the result of very, very dry conditions. This is the 3-year rainfall deciles, and this part, essentially most of South Australia, well, the southern part of South Australia and southern part of Victoria had rainfall for that 3-year period, which was either the driest 3-year period on record or above the 90th percentile means, below the 10th percentile, the driest conditions in the, if you like, lowest 10% of all 3-year periods. Here, in this period, is the 2006 to 2009 rainfall amounts. And what it shows, if you work out what this is that we've only had, in that period, that 3-year period, about 50%, about half the normal rainfall. We're missing a year and a half's rain in 3 years. And Victoria usually has a bit more rainfall, has a reasonable amount. It's much the same as Canberra. You look where Canberra is, and Canberra's also missing 50% of its rainfall. There were two parts to this event. The first part was the extreme temperatures that happened in the week, 10 days earlier, last week of January. And this set record temperatures. Melbourne had a bunch of record temperatures, but set a new record temperature for mean temperature, set a new record second hottest day, and set a record for 3 consecutive days above 43 Celsius. It was hot. In fact, most people would say it was bloody hot. And then we had a second stage to the heat wave with a cold front coming in over the 6th and 7th of February, remembering that this is in UTC. So this is really a little bit later than that by 10 hours. And what we see is the front coming in leads to a pressure gradient and wind from the northwest. That wind from the northwest contributes to temperatures, record temperatures, in much of this region. And what we know is that those were the highest temperatures in that dark red region. Many sites in Victoria broke their all-time record, and Melbourne broke its all-time record, and the all-time record was in January. So this was already early February, and it broke that all-time February record by 3 degrees. This is not just a little bit hotter, this is a lot hotter. And that was what led to the fires. I'll skip over the pictures of the fires, there's lots of images, but you can see here, here's just when the fires started with winds from the northwest, and you can actually see the plumes above the fires and then the smoke spreading out. And this is after the cold front comes through with southerly winds, immediately after the cold front has come through. There was a Royal Commission into these bushfires to consider the weather conditions, and the conclusions of the Royal Commission into these bushfires was, yes, the death toll was major, but the weather conditions were not extreme. despite submissions from the Bureau of Meteorology and CSIRO and myself and Neville Nichols, all independently, pointing out that the weather conditions were extreme. And the conclusion turns out to have been based on legal arguments, not on scientific arguments. And the legal arguments were that if this was extreme, then potentially the liability of the electricity infrastructure operators could claim this was act of God, and they might not have been liable for the stretching and fires associated with sparking from the power lines. And they wanted to avoid that. So no matter how hard you might want to work as a scientist, it might not have an impact sometimes. So, were the conditions extreme? Well, the easiest way to look at it is to look at the different sorts of conditions. Most fires in southern Australia are associated with very dry preceding conditions, very high temperatures, strong winds, and low relative humidity. And in particular, what was particularly damaging with these fires is the big cold front led to a change in the direction of the fires from moving from the northwest to the southeast to a change that meant that the front of the fire changed completely with southwesterly winds, and you had a much, much bigger head on all the fires. What had been the flank suddenly became the head as the fires changed direction. The usual way that fire danger is talked about, the fire conditions, is through an empirical index called the Macarthur Forest Fire Danger Index. It takes into account temperature, rainfall, relative humidity, and wind speed. The previous record temperature for Melbourne was on Black Friday, 1939. And the Forest Fire Danger Index then was used to essentially set or calibrate this empirical index, and the value that was considered to be the maximum was 100 from 13th of January of 1939. That's one of the reasons why Friday the 13th isn't a particularly good day in Australia, because that was the day of those Black Friday fires. And it was considered that suppression of the fires, it has a range of categories. At that stage, extreme meant more than 50, and it wasn't felt that anywhere could have values above 100. And there were numerous sites on the 7th of February in 2009 that had fire danger index well above 100, including in some locations values up to 200. Yep.
Just an idea of how they're calculated? What is it based on?
As I said, it's based on a numerical combination of maximum temperature, cumulative rainfall deficit, relative humidity, and wind speed. I can give you the formula, but well, the problem is it's an exponential formula that has a bunch of estimated coefficients so that they can be essentially normalized to 100. It was based on previous fires up to 1939 and some controlled burns. Someone actually lit, acre regions of eucalyptus in different weather conditions and tried to measure how rapidly or how extreme the fires were.
The other thing worth noting, David, is that you were talking before about how a rainfall extreme in Melbourne is different from a rainfall extreme in Darwin. The FFDI gives very different results for Tasmania, for example, than Victoria.
Yeah. It was based on essentially southeastern Australia. Does actually take into account vegetation type. No. because it's only designed for dry sclerophyll eucalyptus forest. That's correct. Fuel load is not taken into account in terms of estimating the intensity. So, you know, to get FFDI values greater than ever observed before would indicate that these were extreme fire conditions. The biggest contributor to those was the extreme temperatures and the very, very dry conditions, which led to low rainfall, well, large rainfall deficits and very low relative humidity. That's why it was recorded. The winds weren't recorded by any means. The arguments that were used in the Royal Commission to justify not saying that this was not extreme weather conditions are hard to understand, because it was record temperatures, record low humidity, and record drought, low rainfall. But the lawyers got it accepted. There's another very, very interesting series of rainfall events. I'm not going to go through it in detail, but 2010, 2011, 2012 was a repeated series of La Niña events. La Niña events are often associated with heavy rainfall in northern and eastern Australia. The Bureau of Meteorology typically puts out 1 to 3 per year special climate statements, and they put out special climate statements when they're trying to explain extreme weather or climate events, like extreme rainfall or extreme high or low temperatures. In 2010-2011 period, from middle of 2010 to the middle of 2011, they had 10 statements, more than any other 12-month period. And then they got frustrated by putting out so many and didn't have enough people to keep putting them out, so they slowed them down. It was a period of extreme rainfall in both Queensland and Victoria, and flooding, and a Category 5 tropical cyclone, the strongest at that stage tropical cyclone to make landfall in the Queensland coast. All of those are likely associated with the La Niña event. But one of the other things that happened was a locust plague in 2010, because the rainfall produced more food for the locusts to live off, and fires in Western Australia, because La Niña events are associated with weather conditions in the east and dry conditions in the west. So I wrote a little article at one stage describing this as the biblical plagues hitting all at once. We had fire and flood and plague of locusts and tempest from Yasi. That's only 4 of them, but it produced a good heading for an article, even if you don't read the Bible, like me. So this is rainfall totals. So one interesting thing about this period, I should say, is that the rainfall that fell over in Australia from 2010 through to 2012 led to, and you can go and look at the annual rainfall, about a metre of extra water falling on Australia compared to the norm. It's actually more like 1.4 metres. We had 700 mil of extra rainfall in the middle of 2010 to middle of 2012 period. Australia is a pretty big place. So 700 mil of extra rainfall, assuming it doesn't run off all at once, means that it's got to come from somewhere, and a lot of that comes from the ocean. It led to a 3 millimetre decline in global sea level, as well as the rain in some other parts of the world as well, because La Niña leads to increases in rainfall in some other parts of the world, but the biggest increase was in Australia. So work out how big Australia is and add 700 millimetres and assume it stays there, which is a bit of an exaggeration, and doesn't evaporate and doesn't run off. And you can show that actually that estimate of a couple of millimetres is about right. So yes, there was a lot of rainfall. There was also flash floods. And again, the 3-day total rainfall, 0.5 metre or just over, but the daily rainfall in location closest to the Toowoomba and Lockyer flash floods. The really interesting thing is these were not record daily or 3-day rainfalls. They happened in a very short time, in less than an hour, and they happened in locations where the runoff was focused in valleys. Flash flooding is usually associated with heavy rainfall, but not always extreme rainfall. So these were not always, certainly for the Toowoomba and Lockyer floods, extreme daily rainfall in those locations. So 1974 was another period with extreme rainfall over eastern Australia. What else happened in 1974? Sorry? Yep, another cyclone. In terms of climate factors, what happened in 1974? The second strongest La Nina event. And yes, same sorts of things. Brisbane River flooded, massive Victorian floods. Tropical cyclone Yasi was really interesting. It was one of the best forecast tropical cyclones, basically because it followed a track day after day after day. But for people who are weather weenies, this location here had a offshore pressure gauge on an island, and it provided that picture of the pressure variations, and it is the lowest barometric pressure ever observed in Australia at sea level. And it's a almost perfectly symmetric pressure variation, and you can work out from the cyclostrophic wind of the, if you know the speed of movement, you can work out what the distance is. And you can get the speed of movement from back here if you want. You can work out what the cyclostrophic wind should be, and yes, bloody strong. So that's boats being moored on Mission Beach, slightly inland of their normal moorings. The year before, this is the Dunk Island resort inshore of the Barrier Reef, or in the channel in the Barrier Reef. There's a swimming pool. This is a segment of roof, but there is a swimming pool just in there, under the sand. It's not much swimming pool. Well, the swimming pool's probably still there, but it's taken 4 years, 5 years to try and rebuild that because it got hit again in later tropical cyclones. One of the interesting things in terms of Great Barrier Reef and Queensland coast and tropical cyclones is there have been fewer of them in the last 10 years compared with the last 100 years. But the ones that have been coming through have been more intense, and there have been more category 4 and 5 tropical cyclones than in the most recent 10 years. And you'll hear more about that, I think, from Hamish when he talks about tropical cyclones. We worry about extremes because of their impacts, but they're rare. And they occur across multiple scales, and when we're analysing extremes, we've got to think about the data sets that we use, the observations, how robust they are, because if we want to just describe an event, that's fine. You just collect the data at the time, like that data from that pressure gauge for Tropical Cyclone Yasi. But if you want to compare an event to previous events, you need robust and homogeneous data sets, and you need climate models that can represent and resolve the event you're interested in. And that's tough, because the models often don't have high enough resolution, and the data sets often are not homogeneous. That's what makes working on extremes difficult and interesting. So I'm going to finish up. We're going to do a 3-minute exercise. But before we do, any questions, any issues that I've raised, any concerns?
Just that data sets not only are not homogeneous, they don't necessarily capture all of your extreme events in that station.
Yeah, because often the extremes are small scales and the network of observation sites is sparse. Australia is a big country, and if you want to measure extreme rainfall, particularly convective rainfall, you need lots and lots of high-density observations. Sparse networks mean that you can't always guarantee that you're going to get enough representation of extremes. So you might use adjacent sites, but adjacent sites might have different influences from topography. So you may not be able to represent or use rainfall from different sites, neighbouring locations, because they may not have exactly the same statistics. Yep.
Can you prove on homogeneity if you use a reanalysis data set like Barra or NeoIntra, something like that?
You might be able to, in principle, if the reanalysis was good. You've then got to decide what good means for a reanalysis. Because a reanalysis is based on a model to interpolate between the observation points. And that depends a lot on how well that model is able to represent the sorts of events that lead to whatever extreme you're looking at. So it depends on how well it might represent the convective rainfall extremes or the small spatial scale topographic influences on temperature extremes. For instance, Barra won't be able to represent temperature extremes in urban locations because it doesn't have an urban canyon representation. Won't be able to represent convective rainfall extremes, won't be able to represent tornadoes. Depends what sort of extreme you're looking at. So you've got to be careful about whatever you're looking at, is the observational data set or the model data set good for purpose? Might be good for many purposes, probably won't be good for all of them.